Hello, you probably saw that I made a few 360-degree view videos lately. That was the result of a tweet that I saw on Twitter. And after I had made the first video, I was asked how I went about doing it. I thought that I would make this video along with this quick how-to tutorial that I'm going to make available. So check the description below for the link to this Google Doc. This is a very short overview of how I went about doing it, and there are multiple ways that you can go about doing it. Some of them are covered in some of these links that are at the top. I'm not going to cover some of the other things that might be related, such as video editing software, cameras, how you go about taking the output from a 180 or a 360 degree camera. So I'll let you figure that out on your own. There are a few requirements that YouTube needs, and this is going to be true for just about every kind of video out there. There are certain codecs that are supported, certain formats, along with reasonable resolutions, etc. And I'm pretty sure that YouTube only downcasts. So if you want a high def output, you're going to need at least a high def video that you're going to upload to them. So now I'm going to get to the meat of what this video is all about. I was asked how I go about making my videos, and it's a fairly simple, straightforward process. The first thing that I did was I created a series of still frame images, and I'm going to show you what a few of those look like. Then I take those still frame images and I make an MP4 video out of them. Then I tag it as a 360-degree video and I upload it to YouTube. So it's basically that simple. I create my images from my Skywatching app that I've been developing over the last few years. It was developed originally to overlay a computer-generated virtual sky over a series of images that I have a couple of cameras pointing into the sky can see, so that we can compare where the computer thinks that the stars should be relative to where they really are. And one of the features that I added to this app was the ability to create a script, and I can tell my app to run the script. So for example, I can tell it I want star trails. I want to start at a specific time. So in this case, this is going to be the second video of predicting how the sky should look in the future. In other words, this is going to be for the June 21st solstice of this year, which is 11 days away. So I set the time accordingly, then I tell it to draw that frame. Then I skip ahead 10 seconds, draw the next, skip ahead another 10 seconds, draw the next, so on and so forth. And then when I'm done, I just clean up and I say that I just want to go back to the current time. That in general is how I go about creating any set of images for just about any kind of video that I want. But in this case, since I want to upload a 360-degree video, I needed to make sure that the aspect ratio was 2:1. And if I want 1080p, that means that I have to make the video twice as high as 1080, which would mean it's 2160. So it's 2160 pixels wide by 1080 pixels high. After I told it the screen resolution and the series of images that I want, I told it to go ahead and do the animation, and that generated all of the sample frames that I wanted to create in my video. Next thing after that is I need to take those images and convert them into an MP4. And so I used the ffmpeg command line utility, and the URL is right there. It should be available on all platforms. I think it's only distributed in source code. But yeah, it looks like people have created pre-built binaries that you can download for whatever operating system you're using. So basically, I use ffmpeg to create a video. This may not necessarily be the most efficient video format, but it is one that YouTube accepts. The version of ffmpeg that I'm using is a slightly older one, and I had to compile it from source on the virtual machine that I'm running, so it doesn't necessarily support the best format, but it works. After that, the only thing that's needed is to tag it as a 360-degree format video, and Google has provided a utility called spatialmedia. It's on GitHub. It's a Python script, and so the process is fairly straightforward. After you download the Python script from GitHub, if you go into that directory, you should just be able to run it with this command. You specify the source video, and it creates another separate video that has the appropriate tags. And then last but not least you upload it to YouTube. So I already did one star trail type video that kind of matched the latitude of the original Twitter post that I saw, and a rough guess placement kind of put it at around 45, 48 degrees latitude. So that's kind of where I put it. I left it at my longitude. So that would have put that sample video for April of this past year somewhere in Quebec, Canada. And the next video that I made, I wanted to not only show what the sky would look like for a different geographical location, such as the equator, but I also wanted to create a video that was a prediction of the future. So I told it to go ahead and create a video for the June solstice. That's going to be in just a few days. That was already done as 360-degree video number 2, and I thought I was going to make a third one for the southern hemisphere, and I chose Sydney, Australia, which is going to be linked to this video. And I also decided I was going to make this one slightly different again. This time I included the graticule lines that should show the right ascension and declination of the celestial sphere. And you'll notice that there are some red lines. The red lines are the lines of declination and the lines of right ascension. The declination line is going to be the celestial equator, and the right ascension is going to be where the sun is relative to local solar noon. Here you can see that the sun is going to be at this right ascension and local solar noon right about there. You can also see two brown lines as well. That is the center of the virtual camera, and in this case I've got it pointing at the horizon, currently at an azimuth of 120. So you can see that the east is right over here. I can change the azimuth and move east. I can look at azimuth 0 like this. For this animation, just to make it a little bit less busy, I also told it to hide the text, which doesn't display the names of the stars. And you'll also notice that in the upper left, I'm not displaying the location, time, or date of that specific image. And then after that, I do the star trail as well. And basically this is what it's going to look like. These are the individual still frames. You can see that the celestial sphere is going to be moving as well as the stars. A couple of things to note. The celestial sphere is locked in on the position of the sun. So you'll notice that the moon is going to move relative to the graticules as well as the stars. And then I'm also going to show what the star trail looks like. The last thing that I wanted to discuss was the projection of the 360-degree view. In this case, there really is no middle of the video because that's going to be determined by the player depending on which direction you look. But in order to generate it, you need to obviously have a middle of the video. And so if you pretend like you're recording a video and let's say you had a magical camera that could look natively in every direction, that camera should project a video that is an equirectilinear format. And what that means is that what is defined as where you're looking directly ahead, that's going to be in the middle of the screen. And as you look up or down, each degree of altitude that you're looking in is going to be along the y-axis, so that your horizontal eye level is going to be in the middle. And as you look up directly overhead, you're going to be approaching the top of the video frame. And likewise, as you look down towards your feet, towards 90 degrees down, it'll be towards the bottom of the image like this. And as you look more towards the right or towards the left, it's going to be the same thing along the x-axis. So the image appears distorted like this because we're taking a 360-degree spherical image and we're distorting it to fit onto a two-dimensional image format like this. And it should work just fine when YouTube takes that image and transforms it back into what looks like a sphere. To say this another way, If you apply a linear transformation of azimuth from directly behind you towards your left, towards your front, towards your right, and then back to your back, project that onto an 18 by 9, or in other words, a 2:1 scaled image along the x-axis, with the vertical component, or the altitude, from directly overhead to directly in front of you, and then directly to your feet along the y-axis. That should be all that is needed for YouTube, and probably for most of the other social media sites out there. According to this URL, it should even work on Facebook as well. So that's going to be it for this video. If you like the video, I would appreciate the thumbs up, the subscribe if you're not already subscribed, all that other good YouTube stuff. And check the description for some links, including the other 360 video that I'm going to be releasing at the same time, which is the June solstice for Sydney, Australia. And with that, I'm going to see you in another video soon enough. So bye for now.